All right, hey calculus, here we go. Lesson 5.3 is our introduction to what we call related rates. And related rates is when we have formulas where we have more than one quantity changing and we're looking at the rate of change of one quantity to another. So we can talk about our area formulas for things like rectangles and triangles. We can talk about our distance and our interest formulas. We can talk about circumference and area of a circle. Here is our Pythagorean theorem, whether we're talking about volume or area of squares and cubes. So we just listed a bunch of formulas here, but you know that you also have different formulas that are on your reference sheet. So we'll kind of make a list of things as we go. All right, so in this first example, we're talking about how we can change one variable with respect to the other ones. So if we're talking about this volume of this cylinder, if I'm going to decrease the radius of the cylinder but maintain the same height, here I end up with this cylinder that's about the same height, but notice if I decrease the radius, I make it a lot skinnier. So if this is my new radius, I can see that my volume is going to end up decreasing also. So second conversation, if we maintain the same volume and we increase the height, how is that going to change the radius? So if I'm making the height bigger, I'm increasing my height, but I'm going to be changing my volume, or if I want to have my volume be constant, then I'm going to have to make sure that that radius decreases. Taller height, same volume, that radius is going to have to decrease. All right. Well, we can look at how calculus gets involved. We can use calculus to investigate the rates at which these different quantities and variables change together. And we're going to do that by taking the derivative. And we're going to describe these rates with respect to time. So whenever we're talking about a rate, we're looking for that rate of change. That is what we know of as the change in our output compared to the change in our input. And of course, that's our derivative. So we're going to be taking these derivatives and we're going to be doing it with respect to time because each x and y is going to be changing together, and that's going to be where we're talking about our rates. All right, so take a look at this. We have an ice cube melting. The key word here is cube. So if I have a cube, I know that each side of my cube has the same distance. So then my volume is equal to side cube. When I find the rate of change, I'm taking the derivative. So here's my original equation. When I take the derivative of each value with respect to time, it's kind of like when we did implicit differentiation. When we took the derivative of our x term, it was in terms of x. That's why that went away. But now each variable is going to have its own rate that we're going to be looking at how they're changing compared to each other. Okay, so I have my change in my volume with respect to time is equal to, and of course this is my derivative, 3s squared. And then of course here's my change in my side length compared to time.